Hi folks, in today's video I'll be presenting my talk from Bixby Winter on powering passive optical networks. It will be a three-part series. In my last video I summarized ABB's Data Center Distributed DC Cabinet, which many of you saw in our booth at the Bixby Winter Conference. The link's at the end of this video. In part one of this series, I'll present a passive optical network and some of the gear used to light one up. To start, what's one of the fundamental differences between a copper network and an optical network? Well, a copper network includes the power needed to run it. An optical network does not. And why not? Optical networks are made up of glass. Is glass an insulator or a conductor when it comes to electricity? As you all know, it's an insulator. So we must provide some external means to power up the optical gear. Now, there are many forms of optical networks. Today, I'm going to focus on the one known as a passive optical network, or PON. It's a point-to-multipoint network. The single point is converted into multiple points using optical splitters. These networks use different wavelengths for upstream and downstream traffic. The head end, or optical line terminal, outputs a single fiber, which is converted into multiple feeds using optical splitters. And these multiple feeds are inputs to optical network units, or optical network terminals. All information is continuously sent to all ONUs, where it's selected by the users. The term passive comes in because these optical splitters have no active electronics in them. They're just glass lenses. The speeds and splitter numbers supported are increasing all the time, and the splitters are made in powers of 2, 4, 8, 16, etc. The upstream topology is a time division multiplex. ONUs are assigned time slots to transmit data to the OLT. But this talk is about powering, so what are we powering? Here are a couple OLTs. These support 8 PON ports, which means 8 splitters, of up to 64 outputs per splitter, for a total of 512 ONTs. They draw about 5 amps at -48 volts DC, or 240 watts. There are optional AC to DC power supplies, and each unit supports dual supplies for redundancy. Much larger units are also available, supporting thousands of ONTs, and obviously requiring much more power. Here are a few ONTs. They receive DC power and optical in, and output power over Ethernet, or PoE. The DC input range is typically -58 volts down to -46 volts, and they draw anywhere from 30 to 70 watts or so. In subsequent videos, I'll present the two main ways of powering a passive optical network, and the details for each method. As always, if you'd like help powering passive optical networks or anything needing power, please give us a call. We're here to help. Thanks for watching.